Example 5 just covers two vocab words that you would have learned last year in geometry, but they use in some of these problems. So there's nothing new in what you do to solve these problems. They're very similar to the ones you've been doing. There's just two new vocab terms, and those are the angle of elevation and the angle of depression. And these are always drawn from the horizontal. If you remember that, you'll always draw the picture correctly. So if I tell you that the angle of elevation from the ground to a plane tells me that the ground is here and a plane is up here. I can't draw for the life of me, so you're going to have a P be the plane. The angle of elevation is this angle, theta, from the ground to the plane. If you were told the angle of depression from the plane to the ground, here's the plane, here's the ground. The angle of depression, remember it's made from the horizontal, so horizontal is there. Here's theta. Okay, so it is always made from a horizontal, it is never made from a vertical line. So these red lines that I'm drawing here never make angles of depression, those are bad. Notice that these two angles, theta, would be congruent to each other because they'd be the exact same angle because the horizontals are parallel to each other, so these are alternate interior angles. So the angle of depression and the angle of elevation are actually the same angle, you just draw them differently. So let's look at an actual problem using this. So example 5 says that we're in Telluride, Colorado, and there's a free gondola ride that provides a spectacular view of the town and the surrounding mountains. The gondolas that begin in the town at an elevation of 8,725 feet travel 5,750 feet to Station Sophia, whose altitude is 10,550 feet. So the first thing I want to do is find the angle of elevation from the town to Station St. Sophia. So here's the town right here, and it is already 8,725 feet in the air. That's the elevation of the town. And then Station St. Sophia is up here, and it is 10,550 feet. That's its altitude. It says the length of the gondola ride is 5,750 feet. What is the angle of elevation from the town to the station? Boom. That's the angle I want to know. Now let's see. I know the hypotenuse of this triangle. This 8725 goes with the altitude of the town. Notice I could find out the opposite side. I know this whole thing is 10,550, and I know that this part is 8725. So what remains is the opposite side of this triangle, which is 1825. Now, I want to find theta. I've got the opposite side and the hypotenuse, so that's sine. The sine of theta is opposite 1825 over 5750 adjacent, hypotenuse. Now again, this is inverse trig because I'm trying to solve for the angle. So the inverse sine of 1825 over 5750 is going to give me what theta is, and when I type that into my calculator, remember second sine, I get that the angle of elevation is about 18.5 degrees. So that's going from the town up to Station St. Sophia. Now, second part of the problem says that St. Sophia is up here, and it is 10,550 feet in the air. And then I ride down the free gondola ride, 3,913 feet, to Mountain Village, which has an elevation of 9,500 feet. And I want to know the angle of depression from St. Sophia, there's the horizontal, down to Mountain Village. So here's theta. So compared to theta, I know 3913, which is the hypotenuse, because here's my right angle. Now I know that this whole length is 10,550, and I know that this part is 9,500. So then what's left is just a little 1,500 feet. So if you look at this, I know opposite and I know opposite and hypotenuse. So again, this is that the sine of theta is 1,050 over 3913. So I do on my calculator inverse sine of that ratio, and that gives me theta, and it tells me that theta is 15.6 degrees. So that's the angle of depression between those two cities, those two parts of the mountain. So again, there wasn't any new techniques there. It was just the idea of angle of depression and angle of elevation. So again, on the homework, around page 504, the problems that deal with angle of elevation are 17, 19, 23, 24, and 36. So now that you have that idea down, you could take a look at those.